Hello everyone and welcome to the CSGO ESP tutorial. Today I will open Pandora's box and tell you step by step how we can code an ESP using C#.NET winforms. This is an incredibly simple ESP which does the job, drawing boxes on the characters' positions inside the game. Colors can easily be modified for your preference. Yes, that's right, pink boxes can be done. You can even draw pictures on the enemies with this tutorial. The possibilities are endless. Before we start, I want to announce that for this and upcoming videos, source code will be available in the new membership over at Buy Me a Coffee. For only $5 a month, you get to see all of the code pasted online, plus an exclusive rank in the Discord, where you can get in contact with me. Now, to start the tutorial, we download another template that I've made especially for you guys. Link for GitHub will be in the description. Before opening the template, make sure to run CSGO in -insecure mode. This is very crucial since it allows us to use third-party programs. Okay, so when you have downloaded the template and opened the solution, you should get something like this. ESP temp. Click it down, you get all of these classes and the form 1.cs. Click on that, you should get this winform with a panel that is the wheat color. If you get all of this, then click on the start button and you should get these two lines. So one goes from the origin of the CSGO window, goes to the middle, and then goes down. So this also should stay when you're in game. So if it doesn't stay in game, something is wrong. I've gotten that problem before. I restarted my PC and it worked. So try that if you're having that problem. Let's write our ESP now, since we have the required tools. I wanted to change things up in this video, so instead of finding the entity list, viewmatrix and so on, we will grab the offsets from HasteStumper. I felt like showing once again the same method for the 5th or 6th time was a bit unnecessary. Okay, so the first part will be setting some global variables for us to use. And to reach the code, first of all, we double click on the border of the form. So here we have some code already. Let's remove all of this stuff so we can write from the start instead. Okay. Under the class bracket, we write some first of all offsets for us to use and some colors for us to draw, because we want to draw the boxes with red on enemies, on blue on teammates, or whatever color you want. But we'll write some offsets first of all. So we have the local player. Don't worry about finding these in HasteStumper. I will show you exactly what's the name in HasteStumper. Yeah, it's EV as well, but I'm going to screen. That is almost everything for the global variables. We have some pens, because when we draw graphics on our panel, we will need our specified pen. So we will have a team pen, which equals to new pen color dot blue. The width will be 3 pixels. Now for the enemy pen, just copy paste. Here we just change it to red. And we have the colors, red and blue. Now we will declare our memory read and write object, which will be the swedz library, my own made library. And we will also use the Ezoverlay, which I also made. we will have an entity list. Okay, so I just made an oopsie. We need to use the winform template namespace because our class, no, not that one, our entity class uses that namespace. So go back to the form1.cs, add using winform template. Now we can create an entity or an entity which will be the player. So us in the game, player equals new entity. We also will need a list with the data type entity. So we will store the entities in the game, the information and so on in this entity list. Last of things, or the last global variables, would be the pointers from the client, and no, actually we don't need the engine, we will only read to the client in this tutorial. So we add this pointer client, which is the base of the address of the client module. So now we're done with global variables. Okay, so now that we're complete with the global variables, we will create our first function. So we will need our player's team, which we get from the local player pointer. So we create another function. We call this update local, since it's the local player. In this function, we will create a buffer which equals to swedz.read pointer. So we read the client plus the local player offset. When we have read this pointer, we can set our player team equals to bit converter read to int 32. And now we pass in swedz.read bytes. So we read the buffer plus the team. We start from the index 0 in the bit conversion, and we return our player's team. We need to do this because otherwise we can't tell if it's a teammate or an enemy. Now we're complete with all of the local information that we need. Okay, so we have updated our local information, which is the team. Now we need some entities. So we create another function which we call update entities. In this function, we will create a for loop which loops through each entity in the entity list. So in our list, we will clear it. So this global list we created. And after we have cleared the list, we will create a for loop. So for int I is less than 32, which you rarely see more than 32 players in a CSGO game. You can use more, or for example type 64 entities if you want to read more players. But enough of that. Now let's read some information about this current player in this loop. To get the current player, or read the current player's pointer, we will use a buffer. So buffer equals to swedz.read pointer. We pass in the client and the entity list, but we need to add I times 10 bytes. There we go. This will read the current player or the current entity, and now we will create some variables for that entity's information. So we have the team, which equals to int and read the bytes of the buffer and the team offset. We also need to read 4 bytes, and we start converting from the index 0. So we get the team. Now we just need to get the dormant and the HP as well. What's that? That's not what we need, but copy paste. We need the dorm for dormant. We just change the offset so it matches the correct one. We still read 4 bytes and everything is the same since it's an integer. We read the health, and we're done with that bit. So since we have the team, dormant and HP, we can check if the enemy is dead. I think there is a dead offset, so use that instead of this if you're able to. This is just a lazy way to do this. And we also check if he's dormant or not. If he isn't dormant, we continue the loop. So we filter out the ones that we don't want to read to and go to the next entity in the list. So if we want to continue reading or reading the information of this entity, we get the coordinates, which will be in this variable coords, which is not read pointer but read bytes. Use the buffer again, and XYZ. So it's a 3D vector, and a 3D vector is 12 bytes long since it's 3 floats in a row. One float is 4 bytes, 3 floats are 12 bytes. Now we have all of the information for an entity. So let's create our entity for our list. Variable ent has the x-axis, which equals to what happened there. I clicked something. Alright, which doesn't equals to int32 but to single since it's a float. And read bytes. No. We don't need to read anything since we already read the coordinates up there. But we need to convert our coords variable to x, y, and z. So just change that. But remember, we need to read from the last value. So here we read 4 bytes. Here we read from 4 to 8, and from 8 to 12, 4 bytes apart. For the team, we just set it to our team variable up there, and the health equals to HP, our variable up there as well. So just this. Okay, now we have some information to work with. We have this entity. Let's add that entity to our list. Now, we also need to get this player's coordinates. So, to get the player coordinates, we will need to read the viewmatrix, and we need to have a worldtoscreen function, which calculates the 2D points from these 3D points. So, we convert these to 2D. But we need 2 more functions for that. So let's make them. Okay, so for reading the viewmatrix, we just read all of these floats, so 16 floats in a row, and replace these with the values that we have read. Let's go back to our program and create a new method. So our new method would be called readMatrix. It will return a viewmatrix, which where 16 floats in a row. And in this read matrix, we'll create a new matrix, or var matrix equals new view matrix. We will create a buffer, so var buffer equals new byte. This buffer will be 16 times 4, since a float is 4 bytes and we need 60 more of them. Fairly easy. So this buffer will be swedz.read bytes, and we use the client pointer or the base address, and now the view matrix. For the size, we pass in this size, or just buffer dot length. So now we read 16 floats in a row, since they are all in the same position in memory. To replace the matrix properties, we just do matrix dot m11 equals to bit converter to single, and buffer 0 times 4. So this is the first part. 0 times 4 is 0, but just to show. Now for the first row, just copy and paste 4 times. Change to M12, M13, M14. So this row. And now here we change these values. So 4 bytes, 8 bytes, 12 bytes, just read from or convert from the correct index. For the next row, just copy paste 21, 22, 23, 24, and we continue. So now it's 4 times 4, 5 times 4, 6 times 4, 7 times 4. Copy paste again. 31, 32, 33, 34. Continue 9, 10, 11. 41, 42, 43, and 44. So let me just change that real quick. And there we go, reading 16 floats in a row, and then just replacing our properties with that. But we also need to return that matrix, of course. There we go. So reading the matrix is this easy. Let's create our world-to-view function. Now that we have read 16 floats, we can use these floats to calculate the 2D points on screen to draw our boxes. Now, to calculate, we will use the world-to-screen function. The world-to-screen function is a bit complicated, and I'm sorry to say I can't really explain it. It's my bad that I can't explain it. Maybe in the future I will learn it, but at the moment I can't really explain it. But we use our view matrix, our 16 floats. We use the 3D point, which are 3 floats, X, Y, and Z. We use the width or the width of the screen and the height of the screen. This method will return a point, which are just X and Y coordinates, which we will call 2D, so equals new point. And for as I said earlier, I can't really explain this really well. I will provide other guides on what the viewmatrix is, so since you can't really learn it here, I go watch there if you want, but I will just write the screen function which works for this dx 3D something. This DirectX version for 3D rendering. So we add, or we multiply the M41 by the X axis and the M42 by the Y axis and M43, and yeah, plus the M44. So the viewmatrix is the location of the camera, the angles and so on. It has a lot of values which we use when calculating 2D points. If the screen W is greater than 0.001 float, that means he's in the screen, otherwise he's behind the camera. For the screen X, we do mtx.m11 times x plus m12 times y plus m13 times z plus m14, same as screen W. For screen Y, we do the same, but with 21, 22, 23, and 24. Alright. For the camera A, it will equal the width divided by 2f, and the height is divided by 2, and finally we will calculate the 2D points. So we have float x, which equals cam x plus cam x times screen x divided by screen W. The same will be for y. We just change, so it's minus and cam y we're using. There we go. Let's just convert this to a point. So 2d.x equals int. We need to cast it as an int, because I think point doesn't use float values. And now we just return 2D, but since we're using an if statement, we will also have to return something if it's behind the screen. So if it's behind the screen, we'll just return a new point with the coordinates -99 and -99. So this is outside the screen bounds, which we will have a check for and not draw. So world-to-screen function, and now we can use this in our update entities function. So let's take a look at that. Okay, now that we have the world-to-screen function to use, let's use it when we update the entity list. And since we have created our entity here, it fits to update the 2D point information here as well. So we will update the entity.bot for bottom or feet or origin, which will equal to world to screen. We use the read matrix and we use the entity X, the entity Y, the entity C. We use the width and the height. We do the same for the top of the character, but when we use the top of the character, we will also need a point where is the top of the character. If that makes any sense, but instead of reading the head coordinate or something like that, I will just add 58 to that, since using the head coordinate it's a bit it's more complicated than this. It's not really hard, but this is just an easy and fast way to get a very simple ESP working. So we just manually add in 58 units instead of using the height. So we have now two 2D points, which are stored here. We can get the rectangle from this function already made in the entity class. So we get the location, we get the size of the entity. Now everything that's left is just creating a while loop, a main loop, let's say. So we create our main loop here. And in this main loop, which always runs, so all or while true, we update the local player. We update the entities, and when we have updated the entities, we have 2D points to write to or to draw to. So when we have all of the 2D points of the entity or the entities, we refresh our panel. This will cause the panel 1 to invalidate and redraw itself. So we can just add our instructions in the draw function of the panel. We also need to have the thread sleep to something. 13 milliseconds, it's about 60 FPS if everything happens at in an instant. So 13 milliseconds sounds good. Now to get to the function of or the paint 1.draw function, we just double click on the panel 1. Then you would get this panel underscore paint function, and in this panel 1 paint function, we will grab the graphics. So g equals to e dot graphics paint event args, and since we want to check if there are any entities, since there is no need to draw anything if there aren't any entities. So if entities, oh no, it's called list here. So if our list, global list, dot count is greater than 0, if there are any entities, we will try. So it's a try catch statement. We will leave the catch statement empty. There's no need to grab the information from an exception. We just want to draw the boxes. So we try to draw some entities or some boxes around entities. So here we check if our never mind. Or we need to do a for each loop. I forget. Var end in list So we loop through the entity list, our own global entity list from the start. So this list, which now has information since we updated the entities and local player. So since we have one entity, we can check the current entity. We check if this current entity dot team equals to player dot team. If he equals the player dot team and is within the screen bounds, so if bot, which is our point, x is greater than 0, and it's a lot of ands, and dot bot dot x is within the width, and yeah. Height now instead, since it's the y coordinates. And that's it for the checks. So we just check if he is on screen. Easy enough. Or if its feet are on the screen. If he is on the screen and he is the same team as ours, we will use graphics.draw. And we will draw a rectangle. We will use the team pen. And since we already have a function in our entity class for a rectangle, we can just pass in our rect function here. Perfect. Now for the enemies. But we also need to use else if, since we don't want to draw enemies that are outside screen bounds. So we just copy this as earlier, and the only thing we change is equals player.team. So if it doesn't, and use the same as earlier, but with the enemy pen. Good stuff. And this should be it. Let's start CSGO and test out our ESP. No, we can't start our program yet. First of all, we will need to set our winform to directly attach to the CSGO window. So to do that, we will use some instructions in the form1load function. So first off, we check for illegal cross-thread calls, and we set that to false, so we don't check. Then we get the process CSGO. After we have gotten the process, this updates a global variable in our memory class, which is the process. After that, when the process variable is updated, we can get the module base from our program. So we use swedz.get module base, and we get the client.tll module base address. We replace our client value, which is 0. We replace our new module base address with that, and then we set our winform to invisible. This just set the wheat color to transparent and other stuff. You can check all of this out. Ezoverlay is source. It's open source. The same with the memory class, so you can check all of them out. After that, we use the Ezoverlay to attach to our window, which is Counter-Strike Global Offensive Direct 3D 9. And we use this winform. After that, we create a thread, which you can use using system.threading .NET 6 seemed to already have that when you start a project, but we use threading. We use our main function in the thread, and then we start it. Now, before you can start, you will not see anything. That's because our project, if you go to properties, it's not 32-bit. So go to the build and go to general, platform target set to 86. Otherwise, the client pointer will return 0. So it's an easy way to find out that you're using the wrong build platform version. But when you have set it to 32-bit, we can also fix the little error that I made. I wrote 1 instead of I here. So change in update entities to I. And for the last error that I made, it's in the update local function. So here we read the buffer team and we read 4 bytes. So this is the last thing to fix. Hopefully now when we start it, so we have the game open with -insecure, of course. We start our program, our winform, and it should draw some rectangles over the characters. Beautiful. So you can clearly see that it draws rectangles over the teammates and enemies. This is looking very good. If you want to draw lines, just go down to the paint function, write g.draw line, use the team pen for the teammates, and now for the point 1, we draw from the bottom middle of the screen, so width divided by 2 and the height, so it's all the way at the bottom, and for the second point it will be in the middle, so width divided by 2 and height divided by 2. Oh, whoa. No, it's the entity.bot.x and the entity.bot.y. We're not just drawing a line to the middle of the screen. We're drawing to the enemy's feet, or our teammates' feet. So that's how easy you can just draw lines. And if you want to draw a picture, the graphics function has a draw picture as well. It's very easy to scale and change and do whatever you like to it. I hope you guys liked this video. I will see you in the next one. Leave a like and subscribe.